presentation. He was at the training in Minot when we did that 6 weeks ago or so. And I asked him, how come you guys don't invite me anymore? And he said, well, we didn't think you wanted to come anymore. I said, well, I didn't think you wanted me anymore. So we got that straightened out, and here I am.
It was all kumbaya now?
Yeah.
And then this afternoon, right before I left, one reason I'm late is Tom. So Tom called, and he wanted to chat about some things, and I said, I need to get going because I'm going to Minot. And he said, what are you doing up there? And I told him, and I said, why don't you, if you can, why don't you come out? And you can help me teach. In case I forget something. Okay. So here I am. I did have a problem at 4th Avenue Northwest, where by the park, where they closed it. I did go through the park. I did end up having to come back out through the park, and then I just meandered till I didn't see anything that said dead end or no out, and ended up right here at this traffic light up here, right at the other side of the construction. Okay. What we want to do tonight is fine. If you want to video, that's fine. What's your purpose of doing that?
Just post it on my YouTube channel
For
other people to view.
Okay, that's fine. Let's see here. So what we want to do is be very informal. We want to be very informal. You can't talk about advanced material without going back over just some of the basics, but my intent is to move very quickly through these things, okay? And I would appreciate that if you know the answer, or you think you know the answer, to yell it out for us, all right? And that'll help us move on a little quicker. Can we turn out, Rick, just the front lights, or is it all or none? Or maybe,
we'll see what happens when I hit the switch. How's
okay,
that?
maybe we could turn that,
Back on.
maybe we could turn that
I'm gonna see
room
if I
on
can find
back
the lights in
there.
this room.
I'd find out what room we were in, that was enough to figure out.
Ah, there you go, that'll work, yeah.
And we'll turn off the lights in this room.
And that'll provide some pretty good.
Ooh, I got it, that's you. First question.
Good, Tom.
We can move on.
Very good. We'll move on from there. Thank you, Tom, appreciate that. We've got a lot to go through. What I've done is I've repeated some things in a different way, and we'll go over them twice if we have to, just things that I think are very important to hit home. Of course, I think as you all know, I'm John Paul Martin out of the office, Bismarck office of the National Weather Service. And this would be considered a more advanced training. The other thing I want to do is touch on some of the, do you read the area forecast discussions
Yes.
that we put out?
Yes.
And do you understand a lot of those things?
More or less.
More or less. So we'll talk about some of those things. We'll look maybe at the Storm Prediction Center webpage so that we can see what some of those things are. We'll talk about CAPE and SIN and all that type of thing. So again, appreciate your yelling out the answer if you know it. So why do we need ham radio operators? Here's my thought. If you've known me any length of time, you know I'm very honest. Sometimes painfully so, and this is one of those times. Years and years ago, the National Weather Service, Skywarn goes back to, what, the 70s, right? Mm-hmm. Years and years ago, we desperately needed ham radio operators. We needed somebody who knew what they were looking at. We needed them because you had communications. We'd have net control at the office, and you'd radio in and that type of thing. You were critical to the National Weather Service. Then came cell phones. And the thought was, gee, do we really need ham radio operators anymore? Yeah, but how critical are they? Maybe not so critical anymore. Because everybody has a cell phone. And people can call in and tell us what they see and all that type of thing. And that was like the greatest thing. And it took me about 3 years to realize that, oh my goodness, what a disaster. Because the problem with everybody having a cell phone is that everybody has a cell phone. And everything is a tornado. Everything is rotating. Everything is a wall cloud. Any little dust getting kicked up is a tornado. And I came to realize after about 3 years maybe that something's missing here. And what was missing was you. People out there who know what they're looking at is what was missing. And I've come to realize, I don't know if this is true across the country, if every person in my position has realized this, but I've come to realize that it's more critical than ever to have ham radio operators. And it's a challenge because, as with most groups, do you have fewer people now than maybe you did years ago?
Yes, we do.
For every new person you get, you're probably losing 2 or 3 maybe, right?
Yeah, we've got 2 licenses within the last 2 years, and
Yeah.
one that we're gonna have to grab by the scruff of the neck and get them a license.
Yeah. And you know,
That's all your heads with me.
and the same thing is it's happening with all the civic groups and that type of thing, right? Is you know, people have so much to do today that it's a challenge to commit to everything. In Bismarck, the Central Dakota Amateur Radio Club, they come in and work the net control, but you know, there's only a select few people who like to do that, and maybe only when it's affecting Bismarck-Mandan, or not just Bismarck-Mandan, but the surrounding area. And so we don't have folks coming in to man when there's something going on just through Williston or Minot or Dickinson. You know, they're coming in when if it's for Bismarck-Mandan, and then when it moves kind of through Bismarck-Mandan, you have some folks who are willing to stay a little while till it clears Jamestown, and some who say, you know, I have other things to do, and that type of thing. So what we do now is we page, in Bismarck, we page to let them know, maybe for example a watch has been issued, but they don't come in at that point. We page a second time to let them know, okay, now we need you in. Because you can have a watch for 3 or 4 hours and there's nothing going on. So we don't want those folks coming in the office, if they want to, fine, right? But we don't want them coming in the office and sitting there for 3 or 4 hours doing nothing. You know, I wouldn't want that either. I wouldn't want to be the person in that role. So the point is that fewer hams, fewer people, you know, with net control and that type of thing. More folks who want to kind of be out in the field radioing in, but if you don't have a net controller, well then, you know, you don't have anybody to radio into, I guess, at least at the weather office. So that's the issue. So I've kind of come back to full circle, and again, I'm not sure it's true everywhere in the country, but to me, you're more critical than ever because everything is a tornado. Now again, folks with cell phones, absolutely important. You don't need to be trained to see it's hailing. Or to get a ruler out and measure the hail. And that's very important, and people are calling in on cell phones, hey, I got hail, or social media. Again, wind, you know, you don't need to be necessarily trained to say a tree branch broke off my tree in the wind. Maybe I don't know how high the wind is, but I'm telling you a tree branch is broke off. So that's great, but for the most critical things, flash flooding and tornadoes, we really need the folks who are trained. We need the hams back. Technology has limitations. We'll talk about radar limitations. Spotters add credibility to warnings, and ground truth is critical. Reports boost the forecaster confidence. You know that. If I'm thinking golf ball size hail and you call and say golf ball size hail, or you radio in. Or if I'm thinking pea size hail and you radio in pea size hail, I say, hey, I'm doing a pretty good job. I got a good handle on what's going on with these storms, and the result is more accurate warnings. I did not put radio in here because the only way you're going to be able to radio into the office in Bismarck is if the net control is up down
And
there.
John,
Yeah.
right now, think the wing link is down
Okay.
on the Superlink. That was the last I heard, was that the link at wing was down.
Okay.
And
Did you?
I tried it 2 weeks ago.
Do you get in through Hanover?
No, we go the other way around,
Oh, okay.
through Carrington.
Oh, okay, through Carrington. Okay. I don't know if it's down there.
One of the thoughts that I had, since Jeff has hard times getting out sometimes, especially when Dad's at work, Jeff can run a net control
Yeah.
very well, and he's on the chat site with you guys
Yep.
down there.
And NWS chat?
Yep.
Okay.
And that might be a solution around some of the,
I think that would be a tremendous help. Yeah.
but, yeah.
Yeah.
You got that, Jeff?
Yes.
Okay. And let-
I've
maybe we
already
can
been
talk
kind of
about
doing that a little
Maybe
bit.
we can talk. 'cause
I've been kind of doing that a little bit already this summer.
Yeah. One thing I want to do with you is ask you, do you read the hazardous weather outlook?
Yes.
That product?
Yes, I do.
Okay, what I'm trying to get the folks in the office to do more, is put more into that as far as spotters and that type of thing. There's that statement at the bottom, spotter information. Trying to get, folks to put more into that.
Well, it used to be that way, it'd say highly probable and not probable. There used to be more verbiage on that.
Yes, and then we went to where there's hardly any.
Right.
And I'm trying to bring that back and give more of what's the most, what area is most at risk, and then what's the biggest
Kind of like
risk
SPC
tailwind.
does with their outlooks.
Yes, exactly right. Yeah, Tom?
If I can make an observation, because I've looked at other offices, it appears to me that the Bismarck office waits much longer to say whether spotters may be needed.
Mhm.
I mean, I see will not be needed, will not be needed, will not be needed, will be needed this afternoon.
Yes.
And if you're looking at other offices, spotters may be needed Wednesday,
Yeah.
whatever. So,
Right.
it's just an observation, whether it's right or
I
wrong.
mean, they actually let their people plan?
So,
So that's one thing we're slowly trying to get one by one forecasters to put a little more time into that product. So we'll talk about how we want to work that out then, okay, how we want to change things for the better. All right. Our forecast area, as you know, is the 9th largest of all the National Weather Service offices across the country. Our area is the 9th largest by land of all those 121 other National Weather Service offices. So we've got a tremendous amount of land to take care of. And just for example, yesterday I was called in to help with the severe weather yesterday. We had severe thunderstorms moving through Bottineau and Rolette County and extend down into the Rugby area. I think there was high wind and large hail at Rugby. We had other thunderstorms. Then as these were moving east, they started moving more southeast, and they clipped the northeast corner of Carrington, of Foster County. Couldn't get a report there till today. We had a report just outside of our area in Grand Forks' area of 80-mile-an-hour wind yesterday, so we were confident it was severe in the northeast part of Foster County. But not until this afternoon did we hear about a 70-mile-an-hour wind or something like that near 3 miles east of McHenry up in Foster County. Then we had other thunderstorms developing across Logan and McIntosh counties, dove southeast, so a right-moving storm. Across southwest Dickey County, we had 65-mile-an-hour wind, large hail, and some damage at Forbes in the southwest part of Dickey County. So my point is, and this area was in a watch until 10 p.m., and then slowly, as the weather moved through, we pulled the counties out of the watch. And I think by about, must have been by about 8, 9 o'clock, maybe, all of our counties were pulled out of the watch, or something like that, a little before it expired. So the point there being that we have such a large area that there's multiple areas with severe weather at the same time. Yeah? Is that common? Okay, so your commitment as a spotter, of course, I think you know, is proactive calls or radioing into the National Weather Service when you observe or hear about severe weather, and of course you expect an occasional call from the National Weather Service. This is the radar. We want to talk about radar tonight. I think Rick had mentioned in the email back to me that a little maybe more on radar interpretation.
Yep.
So this is right here, the black dot is La Crosse, Wisconsin. This is La Crosse, Wisconsin. So we've got a kind of a line of thunderstorms moving out of Minnesota and into Wisconsin. Pick a storm, any storm. This is a radar image, the National Weather Service radar image. So maybe different on different apps you have or something like that, but on the National Weather Service radar image, what are the yellow boxes?
Warnings.
What
Severe
kind?
Severe thunderstorm warnings.
What's the definition of a severe thunderstorm?
58-mile-an-hour winds or penny-size hail.
58-mile-an-hour wind or higher, or hail 1 inch in diameter. It was raised from 3/4 inches several years ago, quite a few years ago now. 1 inch diameter hail, that's the size of a quarter or bigger. Is there anything, like say the wind is 80 mile an hour or it's a baseball size hail, is it a very severe thunderstorm warning or anything like that? Or
Just a regular
just a severe thunderstorm warning? And in there we'll tell you, is it the wind or the hail? We'll tell you how fast you should expect the wind to be, how large you should expect the hail to be. So as these storms are moving through, pick one out. and just follow it. And I want to ask you, did your storm change direction? Did it change speed? Did it fall apart or develop out of nothing? Hopefully at least some of you say, yep, I meant one of those things. So for example, our storms are moving east. All of a sudden this guy here near La Crosse dives to the southeast. Right? Change direction. We've got thunderstorms up here that formed out of nothing, and it falls apart. It goes back to nothing. What is this?
Gust front, outflow.
Outflow boundary.
Outflow boundary, a gust front. What we're doing is it's raining here, so we're putting rain down, right? We're cooling the atmosphere. So a cold, relatively speaking now, right? Cold, in other words, 80 degrees is not cold, but it is relative to 90, right? So relatively speaking, we've got cool air here. The cool air is coming down, hitting the ground, and it's spreading out. This is an outflow. It's outflow from those thunderstorms, outflow boundary. It's actually moving to the west. This acts as a little cold front. Whenever you see on the radar one of these boundaries, you got to watch it very carefully. Because oftentimes along these boundaries you'll get new thunderstorms developing. Why? Lifting. What are three things we need to get thunderstorms?
Lift, heat, energy,
Moisture.
instability.
Number one,
Moisture.
moisture.
Yes.
You know, and let's not talk about relative humidity. Let's talk about dew points.
Yes.
Right? Can we get thunderstorms when the dew points are in the 30s and 40s? Absolutely.
Yeah.
Absolutely. Why not? Absolutely we can. But more favorable is what?
60, 70.
Oh yeah, well, 50s. You're jumping way ahead on that. I didn't say very favorable. Dew points in the 50s, yeah, you know, in the 40s we say, you know, there's got to be the three things you need: moisture, lift, and unstable air, right? If one of those is completely missing, probably not going to get thunderstorms, right? But if there's at least a little bit of moisture, maybe you got tremendous lift and it's really unstable, well, that's enough to overcome the, say, the 45 dew point to maybe get some thunderstorms. Now, will they grow severe or not? You know, we got to look at other things. Moisture, but once we get those dew points into the 50s, that's more favorable. 60s, even better. You're talking
70s. It's funny when the dew points are higher here
Yeah.
than they are in Miami.
Yeah. You know, and those 70 dew points is when you get out of the shower and you dry off and you're still wet.
Yeah.
That's the 70 dew point. So that moisture. Once we get the moisture, and in the low levels, here near the ground, right? What's going to bring moisture in?
Well, if it just rained, it's going to be wet.
Well, if it just rained, right? Some moisture there, yeah. How about you got a cold front moving in from Montana? Ahead of the front, which way are the winds going to be?
South.
South, southeast? Probably bringing
Gulf moisture.
higher dew point air up. Higher dew point air. You look upstream, you say, hey, dew point in Minot's 55, Bismarck is 60, Pierre is 65, Sioux Falls is 70. And if that wind is coming from the south, southeast, it's going to bring that higher dew point air up into North Dakota. So we got the increasing moisture, right? And really, it's not necessarily what is the moisture. It's a lot to do with how is it changing. Is it increasing or is it decreasing? You might have a 70 dew point, but if this morning it was 80, it's going down. You're bringing drier air in. But if you were this morning 60 and now you're at 65 at noon and 70 at 7 p.m. or something like that, you know, you're increasing the moisture. So sometimes it's not the number, the value, it's how it's changing, right? How it's changing. Now, so you have to watch out for this, these boundaries. Now down here, let's say down here, ahead of these thunderstorms, this outflow boundary here, what kind of cloud might you see on the front side of that?
Is that a shelf cloud?
Out ahead of the
Shelf cloud?
A shelf cloud. A shelf cloud. Because this is the rain-cooled air pushing out, and there's moist, warm air here. Warm, moist air. And when you have the rain-cooled air coming down, it pushes that warm air up. Right? And in this wedge between the warm and cold, you get a funny looking wedge-shaped cloud to form. Call that a shelf cloud. Call that a shelf cloud. What kind of thunderstorms give you a shelf cloud? What are the types of thunderstorms? 3 types, let's say. The one little old thunderstorm out there pushing along.
Single cell.
Single cell, one little old thunderstorm moving along. How about you get a whole bunch of those storms together, they either line up, or maybe they're just in a cluster.
Multi-cell.
More than one. More than one. On a line, sometimes we say, what did you yell out?
Squall line.
Squall line. Sometimes squall line. What's the big one?
Supercell.
The supercell. You might get a shelf cloud ahead of a line of thunderstorms. You might get a shelf cloud ahead of a supercell thunderstorm. So you got to watch these boundaries because they act as little cold fronts. They can produce more storms. But the other thing they do, is there any negative to those?
To a shelf cloud?
Well,
Or
this outflow boundary pushing out ahead of the thunderstorms. Is there any negative to that?
Straight line winds do quite a bit.
Well, straight line winds along that gust front shelf cloud. Yep. But is there a negative side to getting this rain-cooled air pushing out ahead of the thunderstorms?
It should kill the thunderstorms.
Well, it may, yeah. It may act to weaken the storms. You're now cooling the near the ground. You're cooling the low layers. Let's say the 3,000 feet up, right? Half mile from the ground up a half mile. You're cooling that now. You're stabilizing the atmosphere.
So you don't have much differential heating.
You don't have, right, the temperature has the temperature certainly has fallen.
Right.
I don't know if it's fallen 5 degrees or 15, right? The dew point, it's moist, so the dew point probably has dropped a little bit, maybe not significantly, right? The problem is now you've put rain-cooled air out ahead of the thunderstorm. Now you're moving into the thunderstorm, into this cooler air. That energy may be lost a little bit. Sometimes what happens is these storms will then start to die out, and along that boundary is where you'll get new life forming.
Mm-hmm.
Right? Okay. Not always, right? Not, right? Can happen that way, though. All right. So here's the radar. Your nearest radar is near Deering, right? We call it the Minot radar. It's not in Minot. We call it the Minot Air Force Base radar. It's not the Minot Air Force Base radar. It's near, 6 miles east or 8 miles east of Deering, something like that. Out in McHenry. What's that?
We got a guy coming in from that way.
Out in McHenry County, yeah. So this is the one in Bismarck. Inside that dome, how many Doppler radars owned by the National Weather Service in North Dakota? 3. Yeah, Bismarck, Minot, Mayville, between Fargo and Grand Forks. Now, for you in Minot, you say, thunderstorm's coming in this evening and it's, early to mid-afternoon. I want to see what's going on. Who might you look at?
Montana.
Glasgow.
Yeah.
Might look at Glasgow's radar out there. The Atmospheric Resource Board, that's the state government, they do cloud seeding. They've got a radar in Bowman that runs 24/7, 365 now. They've also got a radar at Stanley that they run only during their season, June to September or so. But they're talking about maybe getting that one to run over a longer period of time too. But those are the 3 Doppler radars. And the one in, I don't know about the one in Stanley to be sure, but the one in Bowman has a Doppler add-on to that radar. You can look at that on the internet. You can look at their search North Dakota Atmospheric Resource Board.
Yeah, you can look at both of them on there now.
Yeah. Oh, and the Stanleys too. You can
Yeah, the
actually,
Stanley, yeah.
on one you could see the airplanes flying around, can't you?
Yes.
And you see how they're
They come and destroy all the storms coming to
Oh,
Minot.
You said that, not me. Okay. Rain
That's what
enhancement,
happens.
hail suppression, rain enhancement. Okay, so that's a dome inside the radar. You know how radar works, sends energy out, energy hits something, raindrop, snowflake, hailstone, birds, dust, whatever. hits something, energy comes back to the radar. It paints a picture. What is that picture that the radar paints when it sends energy out, hits something, and energy comes back?
Talking about that ping in time.
No, the image of the radar. There's different things you can look at on radar. You can look at the 1 hour.
Oh, reflectivity.
Yeah, reflectivity. Think of it that the energy reflected off the raindrop or hailstone and came back to the radar. The way the radar works is it takes slices of the atmosphere. Now this is probably going to change, but no time soon. Right now the radar goes around, right, in a circle, send energy, listen, send, listen, stop, shift up a little, go around again, shift up, go around again. The future is to put panels, so to speak, put panels on the dome, and then instead of taking slices of the atmosphere, you're going to send a burst of energy out.
Phased array.
Yeah,
Yeah.
yeah.
If they get
No.
funding.
No, not exactly.
Yeah, it's phased array.
Phased
Yes.
array radar.
Yes.
If they get
Dual
funding.
pole is the one we have.
Yeah.
Phased array is what's coming. So you send a burst of energy that way, a burst of energy that way, and there's panels doing that. So there won't be any moving parts. We'll cut the number of
Less-
moving
less
parts.
breakage.
So burst of energy, burst of energy, burst of energy, and it'll put it all together into a picture for us. Okay? All right. That's the. I don't think that's going to happen anytime before 2025. Probably not even by then. But we'll see. So energy out, hit something, energy back. Okay, paints a picture. What do we call it? Reflectivity. Now, if it's from the lowest slice is a half degree, 0.5 degrees up. That's called base reflectivity. Base reflectivity. Now, on our web page, you cannot see all the slices, but if you have some software, GR Analyst we use at the office in Bismarck, you can see, you can see the levels. So at the office in Bismarck, we're getting in the data from this slice, then this slice, then this slice, then this one, this one, this one, this one. It drops down, starts over. We get new data, right? The radar can be in precipitation mode, so to speak. Could be clear air mode. Precipitation mode, we might want to scan the whole atmosphere. On a day when there's not a cloud in the sky for 1,000 miles, you just scan the lowest levels, right? Just scan the lowest levels. So we can different scan strategies with the radar. So the lowest slice is the base reflectivity, a half a degree. This is what it might look like. This is the energy returned. Energy returned, right? So the higher you up on the scale, the more energy returned. A little bit of raindrops return a little bit of energy. Big hailstones return a whole bunch of energy. Pieces of buildings flying through the air returns a whole bunch of energy to the radar, right? This is base reflectivity. What's the other reflectivity that we show on our webpage? Composite. Have you ever looked at the composite reflectivity? What is that? Anybody know what that's showing? What that's doing is it's taking all the slices, right? And it's showing you the highest returned energy from all those slices. It doesn't tell you where it is. It could be from this one or it could be from this one. It doesn't tell you. It's just showing you the highest returned energy. So it'll always look worse, so to speak. It'll always look worse. Well, I shouldn't say that. It'll always look equal to or worse than the base, because if it's getting it from the base, then it's going to display that one, okay? Why is that important? Why is it important to see that there's high reflectivity returned from, not from here, but from up here? Say 25,000 feet in the storm, there's high reflectivity.
It's a taller storm.
Why is that important?
Taller storm.
Hail.
Well, okay, a taller storm, because generally speaking, right, the taller the storm, the more intense, right? Generally speaking, that's true. Rule of thumb. Maybe not always, but generally that's good. And what's the other thing?
More, bigger hail.
Yeah, maybe that's big hail up there. Well, if there's big hail up at 20,000 feet, 25,000 feet, it's got to come down. It may not come down here, it may come down over here, but it's got to come down. That's why, we may issue a warning for that. You look at the base, or folks who look at the base say, gee, this doesn't look so bad. But they're not looking at the scan higher up. Okay? The other product we get from the radar is velocity. The radar energy goes out, hits something, energy back. Not only I hit something, I'm going to paint a picture, but it can tell, is that object moving away from the radar or toward the radar based on the change in the frequency, right? Toward or away. Doppler radar paints it green if it's toward the radar, red if it's away. Now that's the opposite of what I think it should be. Because to me, red means danger, must be coming toward you. But I don't know who thought of this, but they must have a good reason why it's opposite of what I think it should be. Anyway, so that's the velocity. Now, as you go farther away from the radar, what's the problem?
Earth curvature.
The Earth is
being
curved.
keeps going up higher. Like
That's
look
right.
at radar. Any storms around Williston, you can see that. Is that the beam is really high up versus what it would be if it was in Minot or Stanley.
Correct, yes. So exactly right. So the farther you go away from the radar, the higher up the energy is in the sky because the Earth is curved. So for example, from the Minot radar, what we call Minot, to Williston is up at about, depends on where you are in Williams County, but just, let's say 10,000 feet. Let's just say 10,000 feet. In other words, I can't see anything below 10,000 feet at Williston. Same thing when you go to the east, right? How far is Rugby, roughly?
64 miles.
So, okay, well, so Devil's Lake, or whatever it would be, right? So Devil's Lake, same thing, it'd be up at 10,000 feet. Now we got Mayville there, that might be closer to Devil's Lake and all that kind of thing, right? So the issue there is, though, thunderstorms are not 10,000 feet tall. They're 30, 40, 50, 60,000, 70,000 feet tall. So I can see the thunderstorm over Williston, but I cannot see the lowest, say below 10,000 feet. Well, that's important. That's very important, right? What's the problem right over the radar? The problem right over the radar is that the scan only goes up 19.5 degrees. That's the highest it goes up. It does not go 90 degrees up. It does not go 90 degrees. So I've got a cone of silence right over the radar. Cone of silence right over the radar. Thunderstorm's moving toward the radar. I can see the whole thunderstorm. It gets in closer. I cannot see the whole thunderstorm anymore. The radar might make it look weaker. People look and say, hey, every thunderstorm that comes toward that Minot radar weakens, and then when it comes out the other side, it goes stronger again, right? Because when it comes out the other side, now I can see more of the thunderstorm again. The other thing with the radar, there's that cone of silence again. So I cannot see the whole thunderstorm over Bismarck, over Deering, 80s, whatever. And farther away, I cannot see the lowest slices. And here's why that's important. Oh, no, what happened to my storm relative? I guess I don't have that in there right now. Coming up. So, why we need spotters? Again, the farther you are away from the radar, I'm not seeing the bottom of the storm there. Okay? All right. What is severe? You already answered that. 1-inch diameter hail or greater, 58 miles an hour or greater wind. Tornado. Is that a tornado or a funnel cloud? Tornado. Violently rotating column of air extends down from the thunderstorm. This is the condensation cloud. Nothing here, but you can see the dirt, debris swirling on the ground even from one picture. So you say that is on the ground. That is a full-blown tornado. Tornadoes are rated, what's the scale called?
Enhanced Fujita.
Enhanced Fujita scale. It goes 0 to 5. 0 is the weakest, 5 is the most powerful. Here's the problem with the old scale was, if the building were gone, it was rated a 5. Didn't matter if the building was 200 years old, and if we'd have leaned on it, it would have fallen over, right? So engineers said, you got to do something about that scale. The other thing was a 5 was 300 miles an hour and higher. And engineers said, it does not take 300 miles an hour to destroy a house. They're not built as strong as you think they are. So they adjusted the scale. The scale is a wind scale or a damage scale?
Damage.
It's a damage scale, not a wind scale. The wind kind of falls out of it. And we have damage indicators. There are 28. Single-story house, kind of your wooden structure. Or maybe it's brick, so there's a special case for that. Automobile showroom, strip mall versus like the Dakota Square Mall, right? There's school buildings. Is it elementary type? Is it a high school? Or is it multi-level? All these different damage indicators that when we have a tornado and we come out to assess the damage, we look for. All right, there's trees. Are they softwood tree or hardwood tree? All right, poles. Are they metal light standards like you see on the, the state highway coming through town, or are they wooden poles, that type of thing? Towers and things like that we have. So there's 28 damage indicators, and then each damage indicator has a degree of damage. There's as many as 10. Not all of them have 10, some have only a few. But there's degrees of damage. In other words, the first sign of visible damage, then there's, on a house it might be shingles torn off. Then it's, part of the roof torn off. Then it's half the roof gone and some walls knocked over. Then it's, so how badly is that thing damaged? So you find your damage indicator, you go up the scale until you say, nope, I don't have that, and you drop back to the next lower one, and that gives you a range of possibilities. It gives you the EF, and it gives you the range of the wind speeds. So this is for, say you determine it's an EF3, now is where the quality of construction comes in. If you say, hey, not very strong, not very well built, you go on the low end, well built, you go on the high end, kind of thing. All right, just so you know how we do that with damage surveys. And of course, flash flooding. This is a problem because when in Minot by the city hall, when that they did a lot of work now, I noticed last time I was over there, the railroad track goes over, right? There's a little tunnel underneath.
6th Street underpass.
Yeah, is it 6th Street?
6th Street underpass.
They did a lot of work there. Has it solved the problem there? I don't know if it solved the problem.
Don't know yet.
Today, and the east side was still underwater.
Is it complete?
I don't think it's functional.
I don't think it's complete yet.
Oh, not complete yet. So it sure helped, maybe not
They're
complete
still
yet.
working on the lift station.
But we have that problem in Minot, right? Dickinson, where Villard goes under the railroad track, Highway 22, I mean, goes under the railroad track by Villard. We have that problem in Bismarck, 7th and 9th. Mandan, on the east side of Mandan. Williston, I don't know.
There are no underpasses that I remember.
They just put that one in on the Dakota
Okay.
Parkway, so I'm wondering how.
Okay, it's been a couple of years since I've been there.
Yeah. So anyway, flash flooding. So in the city, the streets are running curb high, not a flash flood, right? Even if the water is spilling over the curb, across the boulevard, the grass area, maybe even onto the sidewalk, not a flash flood. Streets are designed to flood that way. Okay? The expectation is it doesn't happen every year, but every maybe 5 years or something like that. Yeah, that happens. Designed to do that. You can't put enough drains in to take care of all the water that comes sometimes. But now, here's the thing what would make it a flash flood in the city is 3 feet of water, say, rushing through the streets, water flowing into businesses or homes, doing damage to structures, buildings, we would say that's a flash flood. And then outside of town, out in a rural area, this would be considered a flash flood. Water flowing over the road. You don't know if the road is still there, that type of thing. We typically say 3 feet of rushing water. The little creek that used to flow under the road is now flowing over the top of the road. 2-3 feet deep, we'd say, yeah, that's flash flooding. How familiar are you with the severe weather outlooks that were changed about 3 years ago, Tom? Maybe something like that, 4 years ago. Are you very familiar with those?
I'm familiar with them.
Okay, let's do it real quick here. This one has all of them, and we can look at today's if we want. So outside where there's no shading is no thunderstorms, right? Then there's the general thunderstorm area. Thunder, this light green. Saying, yeah, thunderstorms possible there, Springfield, St. Louis, Springfield, yeah, that's right, there's 2. Fort Smith, Thunderstorms today, we don't think they're going to be severe. Okay? Marginal is, they're getting close, right? There may even be a severe one, but you know, that nickel-size hail, maybe 40 mile an hour, 50 mile an hour wind, kind of close, right? That's that dark shade of green. The slight, the yellow, slight risk of severe weather. We think there's going to be some severe thunderstorms in there, not widespread though, not widespread across the area, right? Then we're moving up to enhanced, moderate, and high. Wow. Yeah.
Hey, John?
Yes.
Just as it turns out, 2 weeks ago, I spent about 3 hours on YouTube watching storm coverage of this, and they use hams, they use spotters that they have for the TV station, but there's a lot of video on YouTube about that, and how they covered it with ham radios and stuff.
Yeah. And I think I have, yeah. So here's what goes along with it. So understanding those categories. So the thunderstorms, no label, no severe thunderstorms expected. Maybe lightning, you need lightning for it to be a thunderstorm, right? Flooding threats exist with all thunderstorms, so there could be a little bit of flooding. But generally, you know, winds maybe to 40 miles an hour, some small hail, not severe, not severe. That marginal, isolated severe storms possible. They're going to be limited in duration and or coverage, right, and or intensity. Winds, again, you know, 40 to 60, but I mean, the majority of that is, right, 3 mile an hour is in the severe range, and 17 is in the non-severe range. So, you know, that 40, 50 mile an hour wind, hail up to 1 inch, but maybe not quite 1 inch, low risk of tornadoes. So marginal doesn't mean it does not mean there's no chance of severe weather, but if there's one, an isolated one, okay? The slight scattered severe thunderstorms possible. Again, not widespread, but scattered through that area. Kind of short-lived or not widespread. Now, even in a severe thunderstorm watch, you know, tornadoes are possible, right? That's not the primary threat expected, but so in this outlook, 1 or 2 tornadoes, reports of strong winds damaging, with damage, a hail 1 inch, maybe up to 2 inches, and then we just keep going up from there. We increase the hail size a little bit, you know, a few tornadoes rather than 1 or 2, numerous severe thunderstorms, widespread severe weather, and then widespread long-lived severe weather with the high risk. So basically, look for the increasing towards the bullseye kind of thing. The worse as you get into that middle, into the bullseye. This is on the Storm Prediction Center webpage. Okay. Severe thunderstorm watch means severe thunderstorms that develop could be severe. Tornado watch means thunderstorms that develop could produce tornadoes. Flash flood watch, flash flooding is possible. How is the atmosphere set up? How is the atmosphere set up today? Is it favorable for severe weather? If yes, and we think there's going to be some thunderstorms developing, well then those thunderstorms have a chance of being severe. So we'll go with a severe thunderstorm watch. If conditions are set up not only for severe weather, but geez, you know, good rotation, and especially in the low levels and so on, tornado watch. How do we know if the atmosphere is set up right? How do we know what the parameters are?
You send out probes in the morning.
We release weather balloons. I'll show you this real quick just for those who maybe... Has everybody seen the balloon? We talked about it?
I've seen them on your guys' YouTube page being released.
So this is a radiosonde. This is the instrument we use. We release it twice a day. We do this all across the world at the same moment in time. Not the same time, but the same moment in time, right? So we use Zulu time, Universal Coordinated Time. 0 Zulu and 12 Zulu. But we release 1 hour early. So we release at 11 and 23. So we release on the central time clock We release right now at 6 p.m. and 6 a.m. 11 Zulu, 23 Zulu. In the wintertime, we'll do the same thing, except it's not 6 o'clock, it's 5. Because we turn our clocks back, right? Okay. This is a radio sonde. This is the thermistor, measures temperature. As this goes through the atmosphere, through this hole in the top, the air flows through there, we measure the dew point here. Inside the box is a barometer to measure the air pressure. Wind, we know it was here a minute ago and it's here now. You can calculate the wind speed and the wind direction from that. So 5 things we get from this. Temperature, moisture, dew point, pressure, wind direction, wind speed. I'll pass it around in case you're interested to see it. How do we get it to go up? A balloon. Fill the balloon with something lighter than air, helium, or hydrogen. We use hydrogen at the office in Bismarck. Here's the balloon.
Really? Cheaper?
Cheaper in Bismarck to get hydrogen. Yeah. If we stood up and held hands like this here, that's about how big the balloon is when we fill it up. On a windy day, you put more gas in it. Why?
So go faster.
Well, because on a windy day, it's not going to want to go up.
Yeah.
It's going to want to go that way. And you'll have that instrument bouncing on the ground. So we want to get it off the ground quick, right? So you put more gas in it. Okay? Tie a string to this. Tie the other end of the string to the little knobby on there, Rick, that's on the back side, I think. Take it outside twice a day and let it go up. Does it go straight up over Bismarck? No. It goes whichever way the wind is
Because the
taking.
wind is always blowing in Bismarck.
It's always blowing in Bismarck. Yep, that's right. So it goes whichever way the wind is taking it. Okay? We've had them returned from Bismarck. And the farthest away that I know of was Valley City that we had one returned from. Could be farther than that. But that's the farthest I know.
We got one from Colorado, got a Bismarck one. It's been like 5 years ago.
Okay. Yeah. As you go up through the atmosphere, what happens to the temperature usually?
Drops.
It gets colder, right?
Yeah.
What happens to air pressure as you go up?
Should decrease.
Decreases. So as this balloon goes up, there's less pressure on the balloon. So the balloon gets bigger and bigger and bigger. Eventually it'll break. Right? And the instrument will come back down. A parachute is tied onto the string so that it comes down gently, right? So that it's not free fall. It's orange, so you might see it. What is that orange thing? And you go find it, and inside there is a bag with mailing instructions. It does not come back to Bismarck. It goes to Kansas City, Missouri. Picks it up and use it again. Okay? Twice a day, 93 offices across the United States. Bismarck, Aberdeen, South Dakota, Glasgow, Montana are our nearest ones. Rapid City, South Dakota. Okay? We may do, on a day there's a risk of severe weather, we may suggest, or the Storm Prediction Center may call us and suggest that we do a special release at 18 Zulu, which we would let go at 17 Zulu, right? 1 hour early. Okay? We think, there's a risk of severe weather today, and we really want, and it's not just a little risk of severe weather in Bismarck area. It's a severe weather risk across the northern plains. So they may request Glasgow, Bismarck, Aberdeen, Rapid City, all release an 18Z, to do a special release at 18Z, 17Z. All right. Balloon goes up about 1,000 feet a minute. 90,000 feet is a good run. 90,000 feet is a good run. So it takes about an hour and a half to complete the run. All right? The data is coming back in real time. It's coming back in real time being plotted on the computer. If you ever find one of these, there's nothing stored in here. It's all been sent back in real time. After the system detects it's descending, we use GPS and all that type of thing. Once it detects that it's descending, we don't track it anymore. We do not send anybody out to get it. We just hope people return them if they find them. So once it's descending, we stop. They code up. The computer codes up the message. Temperature, wind, level. Temperature, wind, humidity, pressure, right? All the way up, yeah.
Is that GPS unit in there actually measuring the altitude as it's going up?
You know, that's a good question that I don't know. It's being tracked also, and the radio signal is coming back. So I don't actually know the answer to that question.
Okay, so.
The old ones were about 2.5 times this size, and then GPS has allowed us to shrink it down to this size. Yes, it must be, because what it has improved is the exact spot of where it is. So it
The
must
elevation.
be elevation and distance
And,
from.
oh, okay, the spatial coordinates then.
Yeah, you'd say, would it be ASRAN, would it be range and azimuth and range? Yeah, so it must be helping both of those, because the idea is it's much more accurate now, that when it's at this level and it says the temperature now, that it really is that level and this point and so on, all like that. So yeah, it must be helping with those things, yeah. So the data comes in, it's plotted up, it's sent off. Now, have you ever heard of a skew T-log P diagram?
Yes.
Okay.
Yes, I have.
Okay, so that's what this would be plotted on, this data, right? That's what this data would be plotted on. It's also being sent to Silver Spring, Maryland, right? The supercomputers at National the National Center for Environmental Prediction are running on the data. They collect all the data from across the country, not only the upper air data, but surface data as well. Put this all in a computer and run the model out, right? So there's low pressure over Minot today. Where's it going to be tomorrow? Is it going to be over Winnipeg, Grand Forks, or Fargo? Kind of thing. See what I mean? And then based on that, we forecast the weather. Okay? So very critical to determine stability of the atmosphere. Is the atmosphere that third thing we need, right? Let's back up. So moisture, lift is cold fronts, warm fronts type of thing, right? Provide that lift. Or these outflow boundaries can provide lift. And then the unstable air. So how do we know if the atmosphere is stable or unstable? The data from this, right? So if we have a pocket of air at 10,000 feet that's warm, now, relatively speaking, okay, it's possible you'd get a parcel of air rising up through the, we got moisture, we got lift, so we got that parcel rising, and the low layers are unstable, so it's rising up there. It's cooling off, right? The parcel of air, as you go up, temperature decreases, so the parcel is cooling off, right? Maybe even adiabatically, 5.5 degrees and so on per 1,000 feet and that type of thing. So as it's rising up through the atmosphere, it's cooling off. But let's say that the parcel of air is now colder than the air around it, than the environment. It's not going to keep on rising. It's going to turn around and sink back down. That's a stable layer of the atmosphere. A stable layer of the atmosphere. It's not going to allow, you got some upward motion, but it's not going to allow thunderstorms to form because you got a stable layer up here. It's not going to be able to break through that. If there's a very warm layer aloft, what do we say, and you might read in the discussion, that there's a cap. Capping inversion, there's a cap, right? It's so warm at, say, 10, 12,000 feet, again, relatively speaking, right, that parcels of air rising are going to get up there and they're going to be colder than the air all around them. So they're not going to be able to keep on going. How can we break that cap? How can we break that cap? A couple different ways we can do that.
You can get like a little boundary coming through that will, I'm trying to remember the exact term on it. It like a little wave that would come through,
Okay.
and it would punch through the cap.
Well,
Like a little impulse wave would come through.
yes. there's a key word there, though. First thing, I heard somebody say heat or something.
Yeah.
Somebody yell heat?
Well, daytime heating.
Yeah, what do you mean by that?
Well, if you've got it, well, when we talk about it with radio, we're looking at it, it's you've got your layer, but we look at it from inducting, we can bounce radio waves off of that, that's how
Yeah.
dense it is. You can get a differential heating in a specific area, it'll cause a hot spot that you can pop a hole in.
That's right. So in other words, if we could heat the surface enough that when that parcel gets, in other words, the temperature's 80 right now. Parcels rising are going to get to that stable layer. They're cooler than the environment. They sink back down. We warm up to 85.
But difference, like if it goes over an urban area, I'm assuming it's gonna get a jolt of more heat than it would be over a field or something like that.
Yes, because you know when you walk across a grass field and then onto a big parking lot at the mall, over the grass field, you say, man, is it hot? When you walk over that parking lot, you say, holy cow, is it hot?
What would be other sources of heating like that?
Well, if you're bringing in warmer air at the ground,
Okay.
okay? But mainly, and that can do, but mainly it's that heating from the sun.
Mhm.
That's why in North Dakota, our prime time to get going isn't until,
4 or 5 in the afternoon.
well, I would argue even later than that. 7, 8,
6,
9, you know?
How
When
does it-
the sun is still up
Yeah.
at 9 o'clock at night here in
And that,
the end
and that
of
brings
June.
the question, how do you get intensity building at 2 o'clock in the morning?
Oh,
The sun is
well,
set.
That's-
It's a whole
But,
different game.
but see here, hold on, maybe we'll get to that with the next way.
Sorry.
But here's the, no, that's fine, that's good, yeah, that's good. But here's the thing, so we heat the air, we're up to 80 degrees, parcels rise up, colder than the environment, sink back down, we warm up to 85, parcels rise up, still colder, right? 90, maybe you gotta get to 98 degrees, 100 degrees, whatever.
So it's like, you got your threat analysis for the day for storms, and we've had this a number of times.
What do we?
And if it's gonna be sunny all day and it stays sunny,
Yeah,
and there's a lid cap on the atmosphere, there's potential that something later in the afternoon or in the evening punches through and weakens that cap, punches through and creates storms. But if it's cloudy,
right.
more than likely you're not gonna get nothing.
That's why a lot of times if you had rain overnight,
Yeah.
you had some thunderstorms overnight that you maybe didn't really expect. You're expecting the big severe weather late today, right? But last night, we had some thunderstorms move through, and now or showers, and there's a lot of this yuck cloud hanging around in the morning. We're preventing the heating from getting down to the surface. Yeah. So now the question is, are we ever going to get warm enough to break that cap, or you used another word for it. You said lid.
Yeah,
You used the
cap,
word
lid, yeah.
That's not, somebody might say there's a lid, Tom might say, there's a lid on the atmosphere, right?
Yes.
It's like a pot boiling, but I got the lid on there, kind of thing, right?
But what's really crazy is when you have the cap,
Yeah.
or even this weakening on the cap, and you have all the ingredients, and it's hot, and it's extremely hot.
Yep.
The moisture is heavy, and
Yep.
and they're talking, they have like red zone, like high level threat for tornadoes, and nothing happens.
Yes. So one way is heat that surface. I'm at 90, I'm at 95, I'm just not enough. I get to 98, 99, 100, who knows, whatever. That's enough so that when that parcel starts off at 100 degrees, 100, who knows, whatever it is, and rises up, now when it gets up there, it's warmer than the air all around it. It's going to break that cap. Yeah.
First time this year, and I saw it yesterday on your chat room, you mentioned convective temperature, 90 degrees, storms of fire. That happened in the north.
I was going to ask, what is that temperature that you can calculate off the skewed D log P that we used to do by hand, and now don't have to do that anymore, because it's all calculated for you. What is that temperature called? It's the
Convective temperature.
convective temperature. So you want to look for that. You want to look for that convective temperature. If you read the discussion and there seems to be a lot of doubt, right? Is it going to happen? Isn't it going to happen? Well, because I'm forecasting 95 today and the convective temperature is 97. It may not happen. But if my forecast is wrong and we get to 98 today, see what I mean? Over a certain area,
Right. That's when you.
Maybe not over the whole area, right?
Does it seem like it stores potential energy in that?
Yeah.
'Cause when you get the explosive,
Yeah.
we've talked about this, and you've shown us these explosive growths, I mean, just almost like an eight.
I mean, it breaks through the cap and
So
within
fast.
10 minutes,
Here's-
it's like,
Yeah,
it's
yeah,
like,
50,000.
oh my gosh,
Yeah.
60,
It's
70,000 foot
literally,
cells,
you look
you
at the
know?
radar and it's blowing up like a balloon on
Yeah.
there. That's the thing in the discussion. You may sometimes read, the forecaster may actually say, I don't think they really like doing this, but sometimes the forecaster will actually say, I don't even know if we're gonna get a thunderstorm this evening, but if we do, look out. Because I don't know if that cap's gonna be broken. What's another way we can break the cap
So if you have one-
without reaching the convective temperature? How else can we break that cap?
If a cold
You-
front's coming,
you were-
a pulse wave comes through, or a cold front is coming through.
Not at the ground, at 10,000
Yeah.
feet. If we can bring cooler air
Yeah.
in at 10, 12,000 feet, if we can bring cooler air in, maybe there's a little wave, right? A
Well,
short
sometimes
wave.
you'll see it on radar, just like it looks like an outflow boundary, but there's no storms around there at all.
Yeah, yeah.
It's getting close enough to the radar, you can pick it up,
Yeah,
and stuff will just start firing in front of it or right on it.
right. Here's the thing. So if we can bring a little cooler air in up at 10, 12,000 feet, is there an eraser for this somewhere? I got markers of my own, but I didn't bring an eraser. Anybody have a napkin we could erase that with?
There's an eraser over here.
Got it. Here. So if we can bring cooler air in, up at 10, 12,000 feet and lower the temperature up there. So now when that parcel gets up there, it's warmer than the environment. See what I'm saying? Okay. So we talk about long waves. You know what long waves are, right? Right? This is a ridge, right? What do we call that? A ridge of high pressure, right? And this is a trough, right? A trough of low pressure. This is a long wave pattern. But inside the long wave pattern, we have small waves that move through. So, you know, here's this what do you how that, Tom? The pattern over a large area, like on the synoptic scale, a large scale, we have these waves, right? This is called a shortwave ridge. This is called a shortwave trough. And you get these little spin-ups of energy up at 10, 15,000 feet, like you're talking about. Little spin-up of energy that moves through the long wave. We call these short waves. If you read the discussion, you say a short wave, this is what they're talking about. Okay? You may be in a ridge, but there's a short wave back here moving through the ridge. Southwest flow into North Dakota. Here's North Dakota, right? Southwest flow to North Dakota. You're bringing moisture up at the mid-levels. Usually there's a lot of these waves. Sometimes they'll say ridge runner because it'll run over the ridge. Now, the overall pattern here is sinking air. Destruction of clouds, right? But you got a little spin of upward motion right here. And you'll see this on a weather map, right? So as this short wave moves through the long wave pattern, this is where the lift is. This is providing that lift in the mid-levels of the atmosphere. The spin is up here. But you're breaking this guy through a long wave ridge pattern. So you're going to be weakening him. He may not make it all the way through. See what I mean? If he makes it through, now when he gets down here, he's going to be intensifying. He's going to be growing stronger when he's in the trough. Okay? So when we talk about short waves on the discussion, this is what we're talking about. The timing of these is critical because this thing coming through North Dakota at 7, 8, 9, 10 in the evening, coupled with a surface cold front out in the western part of the state, right, with south wind ahead of it and northwest wind behind it. You got the lifting going on, so you got everything lining up. But if the cold front is still out in Montana at 4, 5, 6, 7, 8, 9 in the evening, and this short wave is coming through at that time, things aren't lining up exactly. You're not getting all the ingredients to come together. Okay? All right. You're not getting all these ingredients to come together to work together. Let's say that. All right. So another way to break the cap is to bring colder air in where the warm air is along. Here's a watch box. This is a big one. This is a tornado watch, 12:25 p.m. until 9 p.m. Central Time. This is what, 2010, June 17th. So 6 years ago, a little over 6 years ago. The counties you see outlined in dark red are in the watch. And what we'll do is, as the threat passes, we'll pull these counties out of the watch. We'll say tornado watch canceled for Burke, Montreal, McLean, Mercer, Oliver, something like that. Okay? In other words, we don't want you in Minot to feel like you're under the gun till 9 p.m. if the threat has passed at 7 p.m. Everything's passed. We'll pull you out of the watch. Again, on a radar display from the Weather Service, the big yellow box is severe thunderstorm warning, the red box, tornado warning. Severe thunderstorm warning, large hail, high wind been reported or indicated by radar. Tornado warning, tornado sighted or indicated by radar, reliable report. We've had a lot of reports this year. We had one report, I won't say it's where it's from, but we had one report at the same time. The person said there was a tornado near this town and another one near that town. And I've been through that area enough to know it's very hilly. You couldn't see a tornado at both of those towns at the same time. I was working that event and we discounted it. We discounted their report. Okay, flash flood warning. Flash flooding is expected or it's been reported. Weather radio, our webpage, you got your favorite. I know you got your favorite places to go to get your weather. We're on Facebook and all that social media stuff and all that. Here is the time of day stuff for tornadoes now. We're in the peak time right now in North Dakota for our tornadoes, June and July. So we're right in the middle, about right in the middle of our peak time for tornadoes. But we've had tornadoes as early as March and as late as November. And then time of day, the peak is 6, 8 o'clock for tornadoes. But we've had tornadoes in North Dakota every hour of the day, all 24. Okay? And I wonder about some of these. I wonder how many tornadoes are occurring at 2 o'clock in the morning.
Nobody's seeing.
that
Less
nobody
energy,
sees.
yeah. Well, it's doggone scary.
Or if you're out one of those counties that's quite remote anyhow, that you're not gonna,
And you're flash blinded every time you try to do a report. We
Yeah.
couldn't do it at that time, and that's too dangerous.
Yeah. On tornadoes, yesterday we almost issued a warning for Dickey County. Hope you guys were you watching the radar? South of Jamestown yesterday. There was quite a hook on there. And there was quite a bit of gate to gate, I'll show you this coming up, but gate to gate shear, the toward and away right next to each other. Because this is a gate and this is a gate, and if they're right next to each other and opposite directions, we say gate to gate shear, change.
so it's similar to the turning of the, on like storm relative velocity where you're seeing
Yes, exactly.
it's switching itself around.
It's
Yeah.
not like that. It is that.
Okay.
It is that. Yeah. Okay. So here's the thing. Have you heard of the lifted condensation level? Have you heard of that at all? LCL.
Is that lift
Okay,
index?
here's what it is on the skew T diagram, right? On that cross section, on the vertical cross section of the atmosphere, the skew T, we release the balloon, we get the vertical profile, right? So on one, and I should have just brought some with me. Here's the temperature trace as you go up, right? And here's the dew point trace as you go up. Where these are close together, temperature, dew point, very high humidity. So if this is the sounding from Bismarck this morning, and you said, hey, it's cloudy over Bismarck, how high are those clouds? I would guess they're right there, whatever height that is, right? This is very dry air up here, drier air down near the surface, okay? The lifted condensation level is, you lift this air from the surface, you lift this adiabatically, and where you would have to lift it to where they touch, that's the lifted LCL, the lifted condensation level. It's where condensation is going to happen just by lifting that parcel of air. Where the humidity is going to, think of it this way, where the humidity is going to be 100%, where the temperature and the dew point are going to be the same. Because as you lift it, right, the temperature is going to cool off, and where they meet, the lifted condensation level. If that is too high, it's pretty stable near the surface. And it's going to be hard, I'm not saying it cannot happen, but it's going to be hard to get the circulation through this and down to the ground. And it was pretty high last evening. If you look strictly at the radar, you may have said, why aren't they issuing a tornado warning for Dickey County? And the reason we didn't was a few things. One, it was still daylight, so our thought was, if there is one, somebody will be able to see it. But more importantly, we didn't think that even if we got a funnel cloud, it would be able to make it down to the ground. Okay?
Yeah, I've wondered about that on a few storms. I'm looking at radar and like, there's rotation. It's the couple of radar products I'm looking at are putting TVS signatures on there.
Yes.
And I'm like going, and
Have you asked?
and just, well, why are they not issued a warning on that? I'm like,
Yeah.
I mean, they're seeing the same data I'm seeing. They should be,
Yeah.
you know.
Yeah. Now, part of that is how far are you away from the radar, right?
Mm,
What radar were we looking at last night for Dickey County?
Bismarck, Mayville.
Aberdeen, South Dakota.
Oh,
About 45 miles away as a crow flies or whatever, right? Aberdeen, South Dakota. So it was able to see lower. It was able to see lower than Bismarck. The half-degree slice out of Bismarck was here, but the half-degree slice out of Aberdeen was down here, so we were able to see lower.
can you pull on your guys' radar down there? Can you pull all the radars combined?
Yes.
Okay.
Now, we used to only be able to do it on half-degree, a composite of all the radars. But a new thing just started less than a year ago. It's called MRMS, multi-radar, multi-sensor. It is combining any radar in the area in all parameters. You don't know, at least I don't think you know which radar it's coming from. But not only can it be Weather Service radars, but when they started, they said, we're including Canadian radars.
Oh, wow.
And they asked each office, is there any radar in your area that you want included? And we asked ARB for the Stanley and Bowman to be included in that.
Do they still have the FFA radar out of Williston running?
It's at the Sather Dam west of Watford City.
Can
out
you guys
there.
pull that data at all? I know it's a really old radar.
It's not a Doppler.
And yeah, I know it's a really old radar. Do you guys pull it at all?
Um,
I know you don't have it on your website anymore.
We can look at it, but not, no. We usually don't.
Try to pull the cloud seeder data or
Yeah,
radar
that's
from
right.
them.
That's right, yeah. So we can look at these various parameters from all the radars around. Now, it's better in an area where there's more radars. If you got 10 radars in this area versus 2, well, you know what I mean. But that's something we just got this year. It's not really an upgrade to hardware. It's an upgrade to the software, allowing it to pull, I guess is the right word, pull all these other radars. Yeah. We can display all radars around us. We don't have to, it's in our system.
Yep.
Yeah. Bowman County last year, June 30th, is that a funnel cloud or a tornado? Tornado, absolutely. The condensation ends right there, but you look on the ground, look at that. And hopefully, here it is. This is just a few miles from the South Dakota border in Bowman County.
Now this thing's coming right at their house. Debris on the ground over there. It's hard to see because my window, but the tornado's right here spinning right in front of me. Right there.
Thanks to John for allowing us to use this video. Now he's very close, but he is on the correct side of it, right? Because it's moving with him. It's out of, he's doing the best he can to stay kind of behind it and letting it push out ahead of him. Watch when it goes through this farm here. There it goes.
Holy smoke.
And credit to him, he didn't use a one curse word. Very good. It's very rare that you don't hear a curse word. This tornado, we're only about a mile and a half, maybe a mile from the, this is Highway 85, by the way. And we're on the west side of Highway 85. And it does cross the South Dakota line. It does cross the South Dakota border. Very quickly here, we just took some pictures. Nathan Heider put the pictures together just to show you. This is all wind damage, no tornado from last year. And it's just various pictures from across our forecast area.
Is the wind damage what they had up in Lansford last month?
Yes.
Because some of the pictures, I was just like, some of it looked like it could have been either possible tornado damage. It's just the way that some of the damage looked.
I suspect this is Garrison. I suspect there was a microburst.
Oh,
We had
okay.
widespread damage all across the area.
Yeah, okay.
But it was worse.
Lansford, I was really surprised.
The worst of it was there. I suspect it was a microburst at
Okay.
Lansford. This is just Lake Sakakawea there, just on a windy day. Found that interesting. Water splashing up on Highway 83. What is it, Audubon on the other side? Is that right?
Yeah.
And then some hail. Better would be what in the picture?
Something to measure.
There you go. And these we just take, sometimes we'll go off the web pages, the television web pages, and take, there's a roller. All right. Wanted to just touch on tornado safety outside, right? Do not, now this may protect you from hail, but do not leave the vehicle and get up underneath there for tornado. Do not do that. Do not leave the vehicle and get up underneath there. You may be sucked right out from under there. The chances are you would be sucked out. So don't do that.
Increase velocity under there?
What's that?
Increase
Yeah,
velocity.
yeah. If it's a direct hit, you know what I mean? If it's off in the distance going by, well, but you're not going to know that. Okay, some other damage from last year across the area, and let me see what this is. This is just a little funny. This one we did have to bleep out.
Now, what's the better helmet, the plastic one or the metal?
Better what?
What's the better hard hat, a metal one or a
Oh.
plastic one?
I don't know.
I'm asking actually live in a mobile home.
Okay.
Sometimes you want a flak jacket and a helmet. You're thinking medium metal helmet's not a good choice for lightning.
Try to imagine that helmet, the helmet being hit with that hail with the cha-ching, cha-ching,
Well,
cha-ching.
when it goes through your roof, it's kind of like,
Imagine what it'll do to your back when you hit with that.
hasn't got a direct shot in his window yet.
There they go.
Well,
Yeah.
There's a basement.
away from the window. Yeah, like a bathroom or something.
What year did we blow out the window in our van and went through the,
Oh, I don't
broke
know.
out both your windows and shut those windows?
All
I
right.
don't know. That storm when the RVs got killed the Minot.
Just for your information too, for your safety, if you are getting hail bigger than golf ball size, you should do what you would do in a tornado. In other words, in a tornado, you're going to go to your basement. If you're getting bigger than golf ball size hail, go to your basement. Okay? I'm not saying there's a tornado with that storm, but if that thunderstorm is strong enough to produce bigger than golf ball size hail, it certainly is the chance of you getting a tornado is not zero. It is not zero. So do whatever you would do for a tornado. And then of course flash floods, especially for if you're out, maybe on net, if you're out, at a predetermined location or something like that and radioing in, you come to a flooded road. Do not drive into the water. Do not drive into the water. Enough said about that. 2 feet of rushing water, float your vehicle. 2 feet. 6 inches, knock you off your feet. The other thing we need to be concerned about is lightning. And from 2006 to 2015, 312 people killed by lightning in the United States. 312. Okay? 80% were men.
Yes.
And typical age 15 to 40. You can see the blue is the men, the pink is the females. We beat them in every category, right?
Hey, we're number one.
How many were out on the golf course too?
Golf course, fishing, boating, right? What is this flash to bang 5 seconds, 1 mile? What's that all about?
Travel the speed of sound. How far away was the lightning?
Speed of sound versus the speed of light, right? You count, you see the lightning, you count to 5, you hear the thunder, the lightning struck about 1 mile away. So the general rule is if you're counting to 5, then you're counting to 10 and 15, 20, or 8 and then 13, whatever it is. If the number's increasing, right, the storm's moving away from you, generally. If it's decreasing, you're counting to 28, now you're counting to 18, now you're counting to 15, that storm's moving closer. One thing you have to watch, though, is lightning can strike from this part of the thunderstorm and then this part of the thunderstorm, and it's moving toward you. So you say, oh, I only counted to 5, now I'm counting to 15. It must be moving away, and it's not. So you it's a general rule of thumb, but you got to watch because you don't know exactly what part of the storm the lightning struck from. This is an interesting, hopefully that, maybe it doesn't. Does not work. We'll see if we can find it later. Thunderstorm life cycle. Being born, towering cumulus stage, almost all the motion is upward in the storm. Enter the mature stage, first flash of lightning. It's now a thunderstorm. We have one main area of upward motion, updraft, one main area of downward motion, the downdraft. Mature stage, and then dissipating stage. Dissipating. Okay.
You know, there were some pretty awesome shelf clouds in this last week.
Yeah.
You know, it was amazing how big they were and how pronounced they were across the state.
We had an amazing one come through Bismarck, Mandan on
Sunday night. Sunday night, I was there.
Yeah.
That one seemed almost to be 3 layers.
Yeah, I noticed that. Yeah. I was at a party and then teaching everybody about meteorology, all about shelf clouds. Okay, single cell. Here's the thing with single cells. The updraft and the downdraft are too close together. They're too close together. So that it's raining and maybe even hailing back through the updraft. So if I asked you to stand up, you just stand up. But if I stood behind you and held my hands on your shoulders, right, and pushed down a little bit and said stand up, it's going to be a little harder. So think of it that way. Single cell, the updraft and downdraft, too close together. Some of the rain is falling back through the updraft. What does rain, falling rain do? Cools the atmosphere, right? There's some evaporation going on, cools the atmosphere. Cooler air up here doesn't want to be there, it's going to sink back. So again, you have the updraft trying to push up, but you have some sinking air pushing it down. Kind of fighting, right?
Dissipate kind of quickly.
Yes, that's right. So, if you want the storm to grow stronger, you need some tilt. What do we call that tilt? Shear. We need some shear. We need some speed shear. Maybe we get some direction shear in there. Speed shear will do it for tilting. In other words, the wind here is 20 miles an hour. The wind here is 40 miles an hour. The environmental wind, I'm saying. 20 here, 40 here. So that thunderstorm, when it starts to develop, it's going to start to lean over because the wind is pushing that updraft here faster. So it's going to bend over. That's good if you want severe weather because now the rain and hail are falling out over here. The updraft is no obstructions to it. It's able to just blow up. All right? So you want to separate those updraft from the downdraft. You want the updraft to lean over. A little bit of speed shear will do that for you. Multi-cell cluster. Right? As this one, as this one dies out, a new one forms back here. As this one dies out, a new one forms back here. As this one dies out, a new one forms back here. So they kind of feed off each other. They can be in a line, or they can be in a cluster together. Here's the squall line that somebody mentioned earlier. So this is moving off this way. Where the warm, moist air, or where the warm air is coming in right here, and this cool, moist air is coming out, right here, you get that funny looking wedge-shaped cloud. We call that a shelf. Call that a shelf. When you see a shelf cloud coming toward you, what's going to happen? What can you expect to happen when that shelf cloud passes overhead?
Wind.
Wind.
Rain. Cool.
Okay, temperature is going to cool off. Yes. Wind. What's the wind going to do?
Increase. No, that would be decreasing.
Well,
Shift. Alternate.
shift and increase. See, I'm standing here. I'm standing right here. The wind's at my back. It's a warm wind because I'm in the inflow to the thunderstorm. As soon as this passes overhead, I didn't move, I'm still standing here, but now the picture moved, right? Now I'm here. The wind's not at my back anymore, it's in my face. It's not a warm wind anymore, it's a rain-cooled wind. And it's not the 20 or 30 miles an hour like it was out here, it's 40, 50, 60, who knows, right? Okay. Then is going to come the rain. This is the exact thing that was described at Cole Harbor back, how many years ago, when a lot of folks said it had to be a tornado. And there was a gal with a anemometer about 1.5 miles southeast of Cole Harbor. She measured 93 miles an hour, I think. And she was a trained spotter, had been to a whole lot of training, and she said, saw the shelf cloud coming. Like that. And that's when the wind hit. So you'll get the wind hitting, and you'll be getting dust blowing all around and everything else if there hasn't been much rain. Then you get the rain. Okay? All right. Biggest threat here is damaging wind. So you see a shelf cloud coming, you should be thinking high wind, change direction, temperature drop. Bow echo. The line of storm's moving along, and the wind is stronger here. So it pushes this part of the line out faster than the rest, so the line bends out, it bows out. This is you. Okay, here's the Minot radar over here. Here's Minot, the outline of Minot, here's the base. Energy from the radar went out, hit something, energy came back. It determined this is moving away from me. So the wind today was blown like this. Except for right here. So it's an east wind. It's blowing from Rugby to Minot to Stanley. East wind. Except for right here. Here's our line of thunderstorms. It's a bow echo. The radar over the Minot Air Force Base right there. The readout is negative. That means inbound to the radar. 102.9 knots. 103 knots is what? 120 miles an hour or so, roughly, 119, something like that. So the radar is showing 119 mile an hour at the Minot Air Force Base. Or is it?
Is that the difference between the two of them?
How high up are we?
Yeah.
Right here. 1,121 feet AGL, above ground level. See, on the cursor, I can put it over the storm, and it'll tell me exactly how high up I am in the storm. Above the ground, I should say. Okay? Give me mean sea level and above ground. So what this is telling me is that the wind is blowing this way, inbound to the radar. So it's a west wind coming this way at 120 miles an hour, but not at the ground. At 1,121 feet above the ground. What was the wind at the Minot Air Force Base measured this Saturday morning? 9th of June, 2012? Or is it 2009, June 12? I think it's the 9th of June, 2012. What was the wind measured at the Minot? 93 miles an hour. 93. Not 112, 19. Not 120, 93. So even so close to the radar, we're still up 1,000 feet. What kind of cloud? Shelf cloud. Is it moving toward you or away from you? Is it moving kind of toward us, or is it moving out of the picture or into the picture? Yep, it's moving out of the picture, moving right toward you guys. Here's the rain falling way down the road. Right here, see it? Not raining over here, it's bright. Not raining over here, it's bright. When this moves overhead, wind at our back, shift, wind in our face. 20, 30 miles an hour, shift, 40, 50, 60, who knows. Warm wind, shift, cold wind, or cool wind. Supercell. Highly organized, extremely strong updraft. What makes it a supercell is that the updraft is actually rotating around the storm as it moves up through. We call that a mesocyclone. Mesocyclone. High risk. of severe weather with a supercell. Why do supercells rotate? We talked about that a little bit already. Shear just means a change. Speed, shear, change in the speed as we go up. Direction shear, change in the direction. So here's our speed shear, so that I got to get this updraft to kind of lean over a little bit, so that the rain and hail can fall out here. And it's not falling back through the updraft. This rain-cooled air comes down, and it is sucked back into the thunderstorm right there. What do we call that cloud? Tail of a, it's the tail to the what cloud? The wall cloud. And then the tail will point toward the precipitation. It'll point toward the precipitation, and you'll actually see it growing. I hope I got some videos to show you. Okay. The other type of shear is direction shear. Change in direction as you go up through the atmosphere. To help get that storm, what? Spinning, rotating. Mesocyclone, rotating updraft. Wall cloud. Here's the tail pointing toward the rain. So the rain-cooled air is coming down and being sucked back in right there. What is this called? This brightening of the sky way on the backside.
Rain-free base.
Rain-free base would kind of be in here,
Okay.
right? What is this sinking air way on the backside, on the rear flank?
Rear flank downdraft.
Rear flank, downdraft. On a supercell, you got a forward flank downdraft on the front side, forward flank downdraft, sinking air. That's where the rain and hail's falling out. Then you have the updraft, where the updraft and downdraft meet is where your wall cloud is going to form, somehow in here, right? And way to the back of the storm, you have more sinking air. On the rear side, so we call rear flank, sinking air downdraft. Brightening of the sky way on the back side. Kind of draws this circulation down to the ground. The rear flank, downdraft. We know all about tornadoes and funnel clouds. Let me just show you this. Let's see, is that? No, nothing here you can show there. All right. Largest hailstone in the state of North Dakota, 5 inches diameter. 5 inches diameter. It was somewhere Mercer County, Beulah-Hazen area, 1960 something, and then we tied the record July 14th, 2010. This came out of after we didn't even know. It was during the 10 o'clock news that the thunderstorms just started popping. The cap was broken. 15 minutes earlier, we couldn't even tell you if there was going to be a thunderstorm. But we could tell you that if there was a thunderstorm, look out. Yeah. 5 inches diameter. Microburst, downburst. I've got some videos of these. So how do these form? You got the precipitation, the rain, hail falling from the cloud, right, into the dry air underneath the storm. So when you have rain falling into dry air, sometimes what do we, well, I don't know if it's so scientific to say this, but what do we call that? When you see the rain falling out of the cloud or the snow, but it does not reach the ground. Was it? Yes. Virga. V-I-R-G-A. Virga. When you see the rain falling out of the cloud or the snow falling out of the cloud, but it doesn't look like it makes it to the ground. Why is it not making it to the ground? The air is too dry. It's evaporating. When water evaporates, it's a cooling process, causes the temperature to go down. So you get this cold pocket of air there. And this cold pocket of air doesn't want to be there, right? It's more dense. So it wants to what? Sink down to the ground. So that enhances this downward motion. So as the precipitation falls into the dry air, it evaporates. Through evaporation, the air cools. We said that. Becomes more dense and sinks downward faster and faster toward the ground. Eventually hits the ground and spreads out. They can be dry microbursts or downburst winds, very little if any rain. Or they can be wet, a whole lot of rain with them. All right? This is the mechanism that causes these microburst, downburst winds. Now, every microburst is a downburst wind. But not every downburst wind is a microburst. Microburst is on a very small scale. I think it's less than 2.5 kilometers or something like that. Less than 2.5 kilometers, the rushing down of the wind. If it's over that, it's considered a downburst. Who cares? Who cares? Right? Oh boy, why is that not showing up? Okay. Cole Harbor. Cole Harbor. This isn't that. Yep, oh there. Okay. So here's Cole Harbor, right here. Let's see if we can get that to go again. And watch this sudden, this is a vertical profile. This must be, okay, the surface, 25,000 feet above the ground, 50,000 feet above the ground. So the storm tops are about, 55,000, right? 55,000 feet. Watch what happens. Watch what happens here. It's just going to collapse down right there, right down over Cole Harbor. So a vertical profile, vertical cross section of the radar. Downburst winds, microburst. Here's some of the damage at Cole Harbor.
It's the weather station that was been over.
Dang. Let me do this, because these are too good, these videos, to pass up here. I'm not sure why they're not working in that version.
Thank you all for letting me sit in today. I have to get back to work. And thank you, John.
See you, Tom.
Yeah.
Thanks for coming out.
Oh, by the way, construction.
How's the weather, Tom?
Funny guy. Okay, let's see if that will. Yes. No tornado.
That's my new van, man.
That looks almost like a hurricane.
Yeah.
Yeah, it did that under trees. That's kind of a good idea. The buildings are causing an effect on it.
There we go.
Yeah.
The damage can look like tornado damage from a microburst. Why? Because when the microburst comes down and hits the ground, it spreads out in all directions. Just like tornado damage will be strewn in all, the debris will be strewn in all directions, same thing with this. So it's tougher. It's tougher, you know, with a microburst. It'll primarily be the way the storm is moving, because the storm is moving this way and all of a sudden it drops this right down to the ground. It's going to spread out in all directions, but primarily the way it's moving. Right?
Is the wind going to be more focused
Yeah.
going forward?
Yeah.
Okay.
Where is the wind in a tornado the highest?
The outer edges.
Where I'm at.
Which outer edge? Which outer edge?
The rotating. Oh, shoot.
It's gonna be the leading edge?
With the 12 to 3 position?
let's say your tornado is moving forward this way at 20 miles per hour. And let's say it is producing a wind of 100 miles per hour. In other words, let's just stand it still, not move it. You got a 100-mile-an-hour wind spinning around it, okay? Or within it, you know. Okay. So here on this side, you got the 100 plus the 20 is 120. On this side, it's 100 this way minus the 20 that way. It's only 80 miles per hour. Does that make sense? So it's kind of like an additive. So the damage should be, you know, I guess it depends what's there, right? But the exact same thing here as here, you would kind of expect this to be damaged more than that side.
If the damage was equal, you'd be tempted to say it's a microburst for numbers.
Well,
I don't know. What, you know, what we would be looking for is,
I'm thinking of the pattern of wind damage
Yes.
afterward when you're looking.
yeah. What would be, we'd be looking for is damage, you know, we'd be looking for a path.
Yep.
And if we had a path, you know, that would lean toward tornado. If we didn't, that would lean toward microburst. And then if kind of the things on the edges are pushed that way, you know, and the thing ahead is pushed that way, because with a tornado spinning, you're going to get, you know, kind of
debris thrown 360.
Yeah, yeah.
Might have part of the house over
So-
here, part of the house over here.
Yeah, in other words, yeah, if this house is destroyed but all blown that way, I'd say, oh, microburst. And then this one might be damaged or destroyed and leaning that way, kind of thing, yeah. But it would be tough. And we'd be looking for eyewitnesses. What did you see? And please don't tell me you saw a tornado. Describe what you saw. Describe what you saw. Okay. Let's keep that one up. Let me see, what was the one up here? Oh,
So more likely the tornado's going to pick up something and throw it a couple 100 yards
yeah.
than the microburst. Not saying it couldn't do that.
Or more.
Yeah.
You pick up the
Let me
tree.
see. Oh, here.
Sounds bad.
Yeah.
Let's see, let's see here.
That's why it's a good thing you work evenings.
Yeah, they don't let me loose out in the morning.
Jeff can sit
Okay.
home, run net control, you can be at the factory.
Oh, here. Let's see if we can, get this
Forever.
one.
I will be back. We're going.
Okay, here, look at it. Watch this now. Oh, sorry. Here it comes.
Ooh. Looks like
Oh,
a
yeah.
bomb load.
Water balloon.
No,
Yeah.
bomb load, yeah.
Like somebody dropped a huge water balloon at the sky. Yeah.
Kind of like, almost kind of looks like when they drop the water for like a
Wow.
wildfire and they just drop it and just
Yeah.
rolls out.
Yes. Oh,
That's
it's
a,
fucking like a
God,
helicopter.
yeah.
God, that's a lot of energy.
Yeah. Yeah.
Yeah.
Storm just opened the bomb bay doors and released.
Let me tell you something about microbursts. For us to have I think this is, I feel okay saying this. For the National Weather Service to have a warning out for a microburst is gonna be a little bit of luck. In other words, we're gonna capture a microburst only because we already have a severe thunderstorm warning out. We're already thinking 60, 70 mile an hour wind. We got the severe thunderstorm warning out, and just by chance, now we got a microburst. Because by the time we see this on radar, it's going to be too late to get a warning out with any advance notice. So the only way we're going to get advance notice on this is if we already have a severe thunderstorm warning out, and then does that make sense?
Mhm.
and then get this. I think that's fair to say.
Well, by the time you see it on radar,
Yes.
it's already happening at the
That's
time,
right.
and there's 2-minute
right.
delay on the radar image, and,
That's right,
yeah.
exactly. Okay. That one we saw, you know, the anvil on a thunderstorm, you know the overshooting top, right? That's an indication of intense updraft when it's 75 miles away from you. This thing is out between Stanley and Wollaston moving toward you, and you look out and you say, what the heck is that bubble of cloud up above that thunderstorm? Overshooting top. The upward motion is so strong, it broke through the top of the weather-producing atmosphere for the day. It got there, and it was so buoyant that it didn't just stop and turn back.
We kept going.
It had to expend that energy that
Yeah.
it had, and it kept going, broke through. Overshooting top. This is not the same one, but they're from an airplane. Overshooting top. If you see an overshooting top, and you may see it coming toward you, you may see it as it's going away. You'll never see it when the storm's right over you. You can't see anything, right?
Now, can you get lightning out of those overshooting tops?
Well, you know, there's a thing called, have you heard of the sprites and jets?
Yes, yeah.
Yeah. And I can't remember which is which.
There's a
What
red
is
and a
the
blue. isn't
shoot
there?
up? Is that the sprite or
That's the
the
Sprite.
jet?
Sprite.
And then what is the jet one? I can't remember. But yeah, pilots have reported, you know, seeing lightning coming out of the top.
Well, I was thinking the leading
And then-
edges, because I heard somewhere where they had, one guy got struck by lightning from a storm. He was 40 miles from the main storm, but it was from the overshooting top, and it
Yes.
was only 15
Well,
miles away.
The anvil, you
Yeah,
get
the
lightning
anvil.
coming out of the anvil.
The anvil, that meant,
Yeah.
at the very
The
edge of
anvil.
it,
Yes.
he got struck.
Yeah, yep.
But the main part of the storm was still 40 miles out, but the
Yes.
edge of the anvil was only 15, and he got struck by lightning.
You know
and
what's
killed.
interesting about that is that we used to say people were struck by lightning 10 miles away. So we said, right?
Yeah.
You can be struck by lightning 10 miles away. Then people were being struck 12 miles away. So we said, okay, people can be struck 12 miles. Now it's 15 miles, so we say you can be struck 15 miles away.
And that's from the
Okay.
you know, the anvil, the leading part of the
From the-
anvil.
yes.
The main storm itself was still 40 miles away.
Yes, yes, yes.
So back to the simple question, you're running for the car,
Yeah.
what's the best helmet?
In lightning?
And I'm absolutely serious because
I don't know.
we started to run out and decided not to. And the guys down the rope bush went out, and it sounded like somebody fired an odd 6 off in the house.
Oh,
Hailstones
God, yeah.
were, you could put your whole hand through the hole. And
Yeah.
the guys that went out said, I didn't have a helmet, I didn't have a flak disc, and nearly got killed from the hail.
I don't know. I'm
Are you
not
more-
a safety,
are you more
I'm not a
vulnerable to
helmet
lightning?
safety expert.
Are you
so,
more vulnerable to lightning with a metal helmet or a plastic helmet?
I would say no. Lightning is not attracted to metal.
Okay.
The problem with metal is if lightning strikes like a fence,
Yeah, oh yeah.
now it's going to go down the
Yeah.
fence
It's
till
2
it's
miles
grounded.
down, right.
Yeah. So
We've done
lightning
that
doesn't
too.
say, hey, there's a nice piece of metal. I think it goes.
But if you're the tallest object around,
Well, if
eh,
you're tall subject around and a metal, yeah.
well, it's not gonna do any good.
We've done that. We're not doing that.
Golf club in this hand, fishing pole in that hand, you know.
Mhm.
But, yeah.
Yep.
Okay. White all the way to the ground.
Yeah.
Hail. Why? Ice reflects more sunlight. You're getting, so it's a brighter, whiter looking rather than the dark raindrop rain. So, rain shaft, hail shaft. Which way is the storm moving? Right or left? This one.
Right.
I would say right.
Can you back to the Mamanus for a second?
Yep.
We did encounter those. Remind me why they're not so good.
Well, you will not get any bad weather out of Mamadas,
Okay.
but they are associated with, I can't say a severe thunderstorm, but a heck of a thunderstorm. Maybe it's not quite severe,
Okay.
but yeah, and you'll see them sometimes on the front side of the storm and on the back side of the
Really?
storm. They can, on both
Okay,
sides.
I saw that Sunday night
Yeah, in Bismarck?
in Bismarck.
Yeah, yeah. I was pointing out the Mamadas to people.
And I didn't expect them to be on the backside of the storm.
Yep. Do you know, I think I'm right on this, predominantly I think on the backside.
Really?
But they can be on either
I
side.
seem to have seen them on the front
We've seen them
more
on the
See,
frequently.
that's
Yeah.
interesting that you
Yeah.
say that,
Yeah.
because I think it's more prevalent on the backside. I could be wrong on that. Because
Well,
very
the way
interesting, you
it-
say you think more,
The
yeah.
way it says there is underneath the anvil, and the anvil usually projects off the leading edge of the storm.
Yeah, but there's some push back, you know, back as well of the anvil, the way the storm came. And I think, you know, we'd have to say in this picture, well, no, we wouldn't have to say that, never mind. I was gonna say the storm is moving out of the wall toward us, but there's no reason to
There's
say
no-
that. No, that's not, yeah, I don't know which way that storm is moving. Look that up when you get home tonight. Is anything in that book about Mamadas? Okay. Anything interesting in this picture that you see? When I first saw this picture, I thought,
There's a wall cloud down there.
I don't see much there in that thunderstorm. But then I saw something.
Yeah,
Well, you,
wall
somebody
cloud.
saw, what, did you?
Wall cloud.
Wall cloud.
Oops.
Right?
You look at this
It
thunderstorm.
doesn't have a big updraft.
It doesn't have a big anything,
Yeah.
right?
I would say if I didn't see the wall cloud, if the hill would have been missing, I would say, well, it's building, but
Yeah.
not much more than that.
Yeah.
Yeah, because if that other side hill would have been over, you'd have totally missed it.
I'm surprised. I must be missing something. You know, there's something I'm missing in this picture here, but, yeah, it does not look like a very well-developed storm to me. It
Right on the edge. Or something's hiding it and it's
maybe
far
something
way
about
farther back.
Wyoming. I don't know.
You got it.
Okay,
Yeah, there's a beautiful woman behind every tree. All the trees in that
That's why
picture.
it's brown.
no trees, right?
Yeah.
Let's look at some lookalikes here. Tornado here, right? Generally, not always, right, but generally smooth edges, fairly smooth edges, right? Not the real raggedy and jaggedy stuff. Okay? So, what are these?
Scud.
Scud cloud. Scud cloud. You want to watch them, right? Because if they are
Yes.
going around,
Yes.
well, that tells you what?
You've got rotation.
That tells you
What happens when we chased one from series of these from Carpio to
Yeah.
June, and we had this, it was like, kind of like another worldly type of thing where they were coming down and going up and coming down, going up and spinning, and we never could figure out whether it was bad or.
Scud was doing
good.
weird things.
It was very, very scary.
Rotation.
Yeah,
You know, okay, assuming we're towards the back of the storm, it rained here, and
Right.
we still got some lift going on. So you're lifting that moist air, you're getting these pieces of cloud forming. But again, the key is if these start, as you pointed out, they're rotating around. That tells you, my God, my thunderstorm is rotating. My atmosphere
Okay.
is rotating.
Something's right.
That would be important.
I just saw a picture yesterday of the storms down in South Dakota, and they had ladies saying it had to be a funnel.
Yeah.
And you look up the cloud in the next frame of the video, and you're like, it's not attached to nothing.
Yeah. Yeah.
It's Scud, and it was ripped up, and it was
Tough. How about here? What if I told you these are not spinning? Are they funnel clouds? No. Little fingers of cloud sticking down. Number one, is there a finger sticking down? Yes. Number two, is the finger spinning? No. Nothing. Number three would be if you said, yes, it's spinning, look on the ground, right? Okay. What kind of cloud is this?
A big one.
A big shelf
Yeah, big
cloud.
one. I like his energy, big one.
Now, careful with this. Do we expect to get tornadoes out of shelf clouds?
No.
No. I'm not saying it could not happen.
You
But
could-
we don't, it's not in our textbook example of how things work.
Could
Okay,
you
so
could
that
you
would be
could you
your
get
first-
a funnel or something very similar? It looks like a funnel
Right.
out of something like a shelf cloud.
Right, but not spinning.
No.
right? So your first inclination would be, that's a shelf cloud. I don't expect funnel clouds and tornadoes out of shelf clouds, but I want to watch it. Nope, no rotation.
Mm-hmm.
Okay, good enough. How about here? Kind of cloud does that look like?
Anvil.
Shelf cloud. You know?
Yeah,
this is where
Same
we get,
thing, yeah.
911, what is your emergency? I see 18 tornadoes, right?
Sure you do.
In a straight line.
Right. Look at it.
Even-
Is it a finger?
even
Yes.
space
Is it
don't
spinning?
know.
No. Is it a finger? Yes. Spinning? No. You got the idea. But again, as a trained, and again, please, don't do this. Don't say, I'm a trained spotter, I'm a ham, I've been to this training lots of times, I could probably teach the class, and so that cannot be. You see what I mean?
It sounds like me.
Would you say that cannot be with your education experience?
What?
Would you say it cannot be with your education experience?
I would not. I would not say it cannot be.
Well, there's a point there between.
When in
not
doubt, ask
reporting
another
and
spotter
should.
at another angle,
Yeah.
position.
Yeah.
What is it?
That's
Can you
what
tell
happened to
anything
us.
better than this?
It's a preponderance of the evidence, based on what I know about meteorology, I would say that is not the right spot for that. But when, it was not November 1st, 2000.
Yes.
Oh, God, yeah. That, was,
Not a
that shouldn't have
time you would
happened.
expect to have 5 tornadoes.
Well, you guys had tornadoes. It was snowing in Minot.
And a blizzard in Dickinson.
Yeah.
That was your cold, hot.
So again, situational awareness that day was low. So please don't do that, guys and gals. Don't say, I got this down, I got everything, because you never know. No rain here, rain here. Is it a finger? Not only is it a finger, it's on the ground. Is it spinning? No. Rain shaft. Rain.
In part because it's not smooth.
Well, in part because it's not smooth. Yes. Most important, it is not spinning. You can't tell that from one picture, but you know what I mean. All right, let's see.
Tornado.
Okay. You got this, right? Who are you? What are you reporting? Report exactly what you see. Don't say it's rotating. What is rotating? How is it rotating, right? Where are you? Important. Where's the thing you're looking at? More important. When did it happen? Is it happening now?
Do the hams there look at APRS data?
Yes.
Okay.
Yes. Yeah. Tornado, funnel cloud, wall cloud, other thunderstorm, shelf cloud overshooting top of rotation, storm dissipation, whatever. Hail size. What size do we report?
Order.
Or
Well,
1 inch or
you got a
larger.
whole bunch of hailstones laying around on the ground.
Largest one possible.
Largest one. The largest one. Don't wait till it gets to quarters to let me know. Any hail at all, let me know. Because we're watching the storm. Right? We're watching the storm.
If it's not 1 inch, if it's smaller and that's the biggest they have,
Yeah.
report it so you guys can either drop the warning or
That's right.
have some idea what the radar's seeing with what's actually coming down.
What was that?
I've seen that on the radar where,
That
where's
piece to
the,
half to-
where you guys don't issue the warning and I'm looking at the radar and it's showing, 2.5 inch hail and I'm like
Yeah.
going, well, I know that's up in the cloud and I know there's melting, but I was like, is it really that far
There's
down?
one piece of software, and since you're recording, I will not say what. There's one piece of software that basically you can take the hail size and cut it by about 45%.
Is that GR level 3?
So if it shows 2-inch hail, you can say, well, it might be a little over an inch.
Okay.
And even our latest, what we noticed with our latest multi-radar, multi-sensor that we talked about earlier, that has a hail algorithm now to calculate size, and that one we're finding you can cut about 25% off.
Oh, wow.
So it might be a little better, but it's still not foolproof. Yeah. So, don't wait till it gets to quarters, because maybe you're getting nickels, and I'm going to say, holy cow, you're not under the core of the storm. So it must be, or it probably is, quarters over there, so I'm going to keep that warning going, based on your report of non-severe weather. Right? Okay. Largest stone. Do the coin thing if you have to, and the ball thing, but measure it if you can. No marbles. You know about that, no marbles. Largest stone, largest stone, largest stone, largest stone. Estimating wind speed, let's not even talk about it, too hard to do. Okay. Hazardous weather outlook is a heads up on our webpage, issued about 5 o'clock in the morning, and then updated every time there's a forecast update, unless it's no change, then we won't update it. Okay? Internet It's not gonna work either, I suspect, no. Do we need to go through this? What kind of storms are these?
Single cell, multi-cell.
Multi-cell, yep. Here, 1,
Yeah.
2, 3. As this one dies out, a new one forms here. As this one dies out, a new one forms there. Multi-cell. If they form a line, what you should expect to see on the front of that line as it comes in. What should you expect to see? What kind of cloud? A shelf cloud. A line of thunderstorms from Mohall to Stanley to Watford City moving this way. You should expect to see a shelf cloud on the front side as it comes through. How long do these last? Lightning, thunder, rain, and all that. Not too long, right? Usually the line is narrow. Maybe a half an hour, 45 minutes, an hour, it's going to be through and the sun's going to be back shining again on you. Yeah. How many thunderstorms here? I would say. This one looks like it's dissipating. It's kind of mushy, right? Here's the main guy, and this guy's trying to build. 3. Earliest tornado on record in North Dakota, March 26, 2003. There's a picture, north of Jamestown, Stutzman County. Latest tornado on record in the state of North Dakota, November 1st, 2000. There's a picture, Highway 1804, north side of Bismarck. 105 that day. Tell me what you see. Tell me which way the storm is moving.
Moving to my right.
Yep.
That way? I would say yes.
Lots of rain.
Lots of rain. Over here? Right under here? What would you call this?
Is that a shelf or is
Somebody
that
said-
rotation?
That's rotation. That's a mesocyclone.
This
Now,
whole-
mesocyclone is a radar term, right? But you look up at a thunderstorm, you say, "Holy cow!" Are you seeing a mesocyclone? Well, you're seeing the effects of a mesocyclone, right? Mesocyclone is a radar term.
Rain free. Yeah.
Part of the storm I can see through the bottom, rain-free base, upward motion
Yeah.
here. Sinking motion
Yep.
over there. Right. Ah! Funnel cloud tornado or not? Not. Kind of raggedy, not.
Not smooth.
You know? How about this? What do you think? One picture, so you don't know for sure, but one picture, what do you think? Just by looking at it. You're gonna watch it, but you should say, no. Very moist. These are probably lifting up into the thunderstorm. Scud cloud, maybe you want to call it scud cloud.
You're not seeing any ground effect.
Yep, that's right. Very low though, right?
Close.
Almost on the ground. Okay. Supercells. There's classic, there's low precipitation, and there's high precipitation. Over here. A lot of precipitation here. Different types. So here's the low, right? Kind of top down, look at it, and then a side look. So some precipitation, but not a whole lot. So we'd say low precipitation, not much. Still get a wall cloud. You can still get a wall cloud, still get a tornado. Here's trying to show you the rotating updraft, and then the pieces of cloud spinning around it, and then compare that to the high precipitation. Low precipitation, we're kind of detached. High precipitation, kind of wrapping around, that kidney bean shape. A lot of precipitation falling out. Wall cloud, this one we've actually got precipitation falling through the core.
Or is that behind the core?
Yeah, well,
On your
far into
cross-section?
the picture,
Yeah,
you
on
mean,
the
right?
on the cross section, it
Yeah.
looks like it's behind the updraft.
Far in, yeah, in other words, way into the
Right.
picture, yes, yeah. What's happened sometimes too is, what's happening is this precipitation is wrapping around that back side, because the whole thing
Due
is
to the
spinning, right?
rotation.
So it's grabbing that rain on that and pushing it on that far way into the wall side.
Then you can have like a rain wrap tornado if something developed.
And, you know, if the tornado did form here,
Yeah.
you couldn't see it from this side,
No,
you couldn't see it from way into the wall that side, and you probably couldn't see it from this side either. You'd have to be in an exact perfect spot. South, southeast, southwest of it, depending on exactly where it is. So this is across a top-down view. Supercell storm moving that way. Here's my gust front. What am I going to find on the gust front? Maybe, most likely, a shelf cloud, outflow boundary, shelf cloud there. So you're going to be here, you're going to get a bang of wind coming in before you even get any rain, right? Here's our forward side, our front side, our forward flank downdraft, all the rain, hail back here. Here's my updraft. Here's my rear flank downdraft, the sinking air way on the back side. My tornado. So if I'm up here, I'm not going to see anything but rain falling out. I need to be somewhere to the south, maybe a little southeast or southwest of the storm. And as it's moving over there that way, I'm kind of following.
So you want to be back on the side where you're feeling the inflow going in.
Yeah,
but you
Yes.
get an included front there where
Now-
it comes together, that's quite interesting.
yeah. One thing you got to be careful of is, you might be in the best spot to see this, right? But this guy starts moving takes a little right turn here. Now you're right in the path. So you got to be very careful with
You
that.
know where your exit routes are.
You really, if you're going to be, we do not encourage chasing, right?
No.
If you are out, you need to know cross roads that you
Yes.
can quickly get away.
That aren't going to float.
Run
Here's a radar image of it. So here's our forward flank downdraft, all the sinking air with the precipitation falling out. Right here is our updraft. That's why there's very little reflectivity here.
Yeah.
Because the rain and hail is not falling there. It's fallen into it maybe a little bit, but evaporating, right? And then back here is our sinking air, no reflectivity. That's our rear flank downdraft. What do you think this higher returns here, this higher reflectivity is right here? If I told you there's a tornado moving.
Hook echo.
Right, well, this is the hook echo right
Rotating.
here, right?
Yeah.
Would that be a debris field?
That's the debris.
Yeah.
That is likely pieces of wood and
Houses
trees
and
and, you know what I mean, flying through
cars.
the air.
Cows.
That's what that is. there.
Cows.
Cows.
Yeah,
Oh,
cows, yeah. There you
Cows
go.
don't fly.
There you go. So, you know, that hazardous weather outlook covers a large area. Maybe several days in advance. In there we put thunderstorm chances could be severe on Tuesday, you know, whatever. We go to a watch stage. That's a smaller area, still large, but smaller area. And then you know the warning is the polygons, valid for maybe up to an hour or so. This is Bowbells, not Bowbells, outside of Bowbells. When was this one?
Is that the one that lady got killed in?
This was a fella. He and his son were in the car. They were from Saskatoon.
Okay.
So here, the Minot, again, Minot radar down here, energy out, hit something, right? Away from the radar painted red, toward the radar painted green. Red, green, right here's our rotation. Here's the gate to gate, right here. We got this going on right here. And that's what you saw with your own eyes if you were there that day.
What's the gate you're showing?
Gate to gate is right here. We've got motion away. See this? Do you see this? This is called a gate. Do you see all these boxes? Can you see the little squares on here? This is a gate, and this is the next gate. So gate to gate, right next to each other, shear, change. So right here, this is motion away from the radar, toward the radar. Away, toward, away, right there. I think there's a better one with, this is just trying to show you the schematic here. Rear flank downdraft, brightening the skyway on the back side. warm, moist air flowing in. Here's our wall cloud, and it's growing. The tail is pointing toward the precipitation, and the rain-cooled air is coming in. This will build. You may see a piece of cloud form here and get sucked in. Piece of cloud form here and get sucked in. Have you seen that?
Yes.
Yes. Okay. Test time. Funnel cloud tornado or nothing?
Well, nothing.
Nothing.
Nothing, yeah.
Funnel cloud tornado, nothing.
Nothing.
Funnel cloud tornado, nothing.
Nothing.
Nothing. Scud cloud. Very moist, being lifted up. Very ragged and jagged, no rotation, according to Rich Thompson. Just a massive cloud, right?
Tornado. Although with the Scud, you would want to keep an eye in that area if what you're
This
seeing.
is somewhere in Tennessee, I think, or Kentucky. Long time ago, right? That sure looks like a tornado to me. It's a little ragged on the edges and jagged, but my gosh, from just a picture, that looks like a tornado to me. There was no rotation, and there was no damage being done.
Evidently wasn't a tornado.
It was
Wow.
not. It was not a tornado.
Wow.
There's a special kind of scud they call this, and I don't know if this came out of this.
Because that looks like on the edge there, it almost looks like a wall cloud.
With-
That
over
thick,
here?
yeah, on the edge there, looks like a wall cloud.
Yeah.
And then like, well, it comes down, it's a tornado. That's what it looks like.
It's worth inspecting.
Oh,
You
absolutely.
know,
Yeah.
you definitely want to have
You
additional
wanna
spotters.
keep an eye on this.
Yeah,
And when you say there's no rotation, you want to forget that you said that and look again.
yeah.
Okay? Scud bomb is the term they.
Okay.
Scud bomb.
I've heard that, but I've not seen an image like that
That
though.
they
I
have,
got hit with a
yeah.
scud bomb.
And this picture, what they did is, I think it's in Tennessee somewhere, and it was either Memphis
Gotta be
or
the
Nashville.
best one
Sent us
ever
out-
on that.
Sent us out and said, hey, is this a tornado or not? And they wanted you to vote, and almost everybody said yes. And it was not. Okay. Moisture we talked about, lift, cold fronts and warm fronts, right? Unstable air. Parcel of air here. Let's see. Parcel of air here, 95 degrees. It's going to cool off as it moves up, but it's still warmer than the air around it, keeps on going. Still warmer than the air around it, keeps on going. Still warmer than the air around it, keeps on going. And eventually it'll become equal to and colder than the air all around it. It'll start to sink back down. So this would be unstable. This would be a stable layer. Can we somehow heat this from 95 to a little more so that when it gets up there it's only say minus 30 or 31 or so? See what I'm saying? Or can we get this minus 33, let's bring in some warmer air to cut this back to minus 28, or whatever, right? What kind of cloud?
Shell.
Who said that?
I did.
Yes.
I'm real good at picking out shelf clouds.
Just don't call everything a shelf, okay?
Yeah, there you go.
Warm, moist air coming in, cool air coming out. That wedge-shaped cloud right there, gust front.
Ooh.
Yes, no, maybe so. What do you think?
Left maybe, upper right, not sure, no, and the bottom right, I think so.
Okay.
Mm,
Farmer
Glad to see you
burning
so
off.
decisive, Dave.
Okay, yeah.
Farmer burning off whatever a farmer burns off,
Oh, here we go.
and the smoke is rising into the cloud. That's smoke. That's a fire. Smoke rising. That is a fire with smoke rising.
Oh,
Have you ever seen the same thing with a guy working his summer fallow?
Yeah, you have to.
Oh, the dust kicking up?
Just like a dust.
A few years ago, well, a number of years ago now, I was at Forfar, sitting on an approach. We had a radio operator at base weather, and they said they had a visual on a tornado 7 miles north of the base. Well, I'm at Forfar, I'm kind of paying
You're right
attention.
there, yeah.
Yeah.
Was that a gustnado?
No, I couldn't see a thing. Another ham was west of the base, looking north. And I asked him later if he saw anything, and he said he saw a guy out working summerfowl about 70 miles north of the base. And it was really kicking up a lot of dust.
You know, I have been fooled by this. Several times going to Skywarn training on the interstate. And I'm like, what the heck is that? And then you get closer, and it's a fire burning and the smoke rising up into the clouds. So you got to be careful. You got to watch it. We talked about that. We talked about this, but just to stress that again, rear flank downdraft. If you have a wall cloud, and the wall cloud is rotating, okay, just because you have a wall cloud does not mean you're going to get a tornado. Let's start over. If you do not even have a cloud in the sky, your chance of a tornado is 0. Right now, right? If now I put a thunderstorm there, my chance of a tornado is no longer 0. It's small, but there is at least some chance. If I can get that thunderstorm to be a supercell, I've increased my chance of getting a tornado. If I can get that supercell to put out a wall cloud, or any thunderstorm to put out a wall cloud, I've increased my chance of getting a tornado. Not saying you're going to get one. I've increased my. If I can get that wall cloud to start rotating, I've increased my chance of getting it, right? If you have a wall cloud, and that son of a gun now starts rotating, and you notice this sudden sinking air, how do you notice that? Because the clouds are going to start lifting, brightening back here. You want to watch very closely, because the next step would be for a funnel cloud or a tornado to form. I'm not saying it's gonna.
And please don't be underneath the thing.
Right.
We have once.
You make sure you're looking around saying, how do I get out of here? Right? And that would be a great
And it's
time.
bad, and it's bad when it gets, the wind stops and it's
Yeah.
dead calm.
Yes. That's the worst.
Yeah.
Add
Add that down once.
A good report would be to the Weather Service, I got a wall cloud, that wall cloud is rotating, and now I can see sinking air on the backside because my clouds are, if you can't remember rear flying downdraft, my clouds are being destroyed on the backside. At that point, they may ask you actually to, can you stay with me? And they may actually issue a tornado warning at that point. I mean, the next step is either things going to fall apart or you're getting a tornado, right? There's no in between. Here's the Bow Bells one. Here's our reflectivity with our hook echo right there. And here's the toward and away right there. See that? This gate and this gate. Here's a gate, here's a gate, here's a gate, here's a gate. And you want the gate to gate right next to each other, shear change right there. So this was in a yellow severe thunderstorm warning. The red is the tornado warning. Here, Joplin, Missouri. This is not huge hail. This is debris. Debris ball. Tornado debris signature in the hook here. Updraft.
Yeah.
See this gate? This gate, this gate, gate. Away toward. There's this. Question is, how high up are we? Is it on the ground? All right. Forward flank, downdraft, updraft, rear flank, downdraft. This is our hook. Probably debris.